Hello and welcome to Nikolai's genetics lessons, and though today's problem is not going to be about genetics, still the methods that we are going to use, statistical methods and combinatoric methods, still applicable to solve different genetics problems, bioinformatics problems and computational biology problems. So it would be good to know how to use these methods. So here's a problem. From a group of 3 boys and 3 girls, 4 children are to be randomly selected. What is the probability that equal numbers of boys and girls will be selected? As usual, I recommend you to pause video here, try to solve this problem on your own first, and when you would be ready, you can run video again and you can compare your answer with my answer and explanation. So, imagine that we have a group of children. Again, we have 6 children. 3 of them boys, so boy, boy, and boy, and 3 girls, girl, girl, and girl. And we have to choose 4 children. And number of boys and girls have to be equal. What does it mean? That means that we have to choose 4 children, and 2 of them have to be boys, and 2 of them have to be girls. Then we would have equal number of boys and girls. Of course, we can choose 4 children, and 3 of them can be boys and 1 can be girl. And also we can choose 3 girls and 1 boy in different combinations, but it doesn't meet this variance doesn't meet requirements of our problem that we should get equal number of boys and girls. So we just exclude this variance from our calculations. So now let's find how many different combinations we can get choosing 2 boys and 2 girls. For example, one combination can be first child a boy, second boy, then 2 girls, a girl and a girl. Another variant would be boy, then girl, then boy, and a girl. Another variant would be boy, girl, girl, and a boy. Another variant would be first child girl, then boy, then girl, and boy. Another variant girl, girl, boy, and boy. And the last variant would be first child girl, then 2 boys, and a girl. So now let's count how many variants we should get 6 different combinations. 1, 2, 3, 4, 5, 6. So we have 6 combinations of 2 boys and 2 girls. And now, next step, we have to find probability of each combination. For example, what is the probability that the first child which we would choose would be a boy? And take a look. Probability would be we have 6 children to choose from, and 3 of them are boys. So probability would be to choose first child boy would be 3 out of 6. Now we have to choose second child, and it have to be again a boy. We already choose 1 child. So now what is the probability to choose a second child boy? And probability would be we're choosing out of 5 children, and 2 of them are boys. So probability would be 2 out of 5. And next we have to choose a girl, and probability to choose a girl would be, as you see, we're choosing out of 4 children, 3 of them are girls. So probability to choose a girl would be 3 out of 4. And probability to choose another girl would be, now we have left 3 children, 2 of them would be girls. So probability would be 2 out of 3. Now, as you see, this is all independent probabilities, so we have to use product rule, and we have to multiply all these individual probabilities. So in the numerator, we are going to have 3 multiplied by 2, 6, multiplied by 3, 18, multiplied by 2, going to be 36. So 36 divided by 6 multiplied by 5, 30, multiplied by 4, 120, multiplied by 3, 360. So 360. And we can reduce both numerator and denominator by 36. And we are going to get 1/10. So this is going to be what we have found. We have found probability of this combination. But we have 6 such combinations. That means that we have to multiply 1/10 by 6. And we are going to get 6 over 10. Again, we can reduce this number, both numerator and denominator. We can divide by 2. And our final answer is going to be 3/5. And this is going to be our final answer. Some of you can be confused. For example, we have different combinations here, and it is obvious that if we'll choose, for example, here first girl, then boy, numbers would be different. Actually, numbers would be the same, just order of these numbers would be different, but we will have all the same fractions. And if we'll just change places of these fractions, this is not going to affect our calculations. Again, take a look at example 3 multiplied by 5 is going to be the same number as 5 multiplied by 3. So if we change an order here, this is not going to affect our calculations. So 1/10, again, individual probability of each combination, and we have 6 such combinations, would give us 6 over 10, and 3/5 would be our final answer. If you need an answer in percentage form, you just have to divide 3 by 5, and you're going to get decimal number, which you have to multiply by 100, and you're going to get an answer in percentage form. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Share this video with your classmates, and see you in the next video. Goodbye.